So on this question for part A, it says, for what values of the constant m is it continuous at 0? Is the piecewise function continuous at 0? Well, to be continuous, I need the limit from the left side, which would be the limit of that, equaling some number. So what is the limit from the left side as x approaches 0 from the left side? That would be of sine x, or sine 2x. Well, as x approaches 0, this goes to 0, and I get sine of 0 is 0. So that gives me 0. Great. And I need the limit from the right side to agree with this limit. So I'd say the limit as x approaches to 0 positive from the right side. And that would be of mx. In fact, it doesn't matter what m is. That's also going to equal 0. Okay, that's great. And if I plug in my x being 0, I would plug it into that one, and I still get 0. So it actually does not matter for the m value. And that's my explanation. I'm not going to write it. Well, I guess I'll write it down. So any value of m will work because the limit from the left side is 0 and the limit from the right side is 0, no matter what m is. So really, I was just checking the limit from the left side if it equals a number, the limit from the right side is if it equals a number, and when I plugged in the specific x value, does it equal the same number all 3 times. And that's really what I'm checking for continuity, because it was asking for continuous at 0. The next part B, asks for if it's differentiable. Let me double check. If it's differentiable at x equals 0, what does b have to be? Or sorry, m have to be? And that I just take the derivative from both sides. What does that mean? The derivative of that would be the derivative on the left side. The derivative of this would be the derivative from the right side. And then I'll compare those, and I have to make them the same because I want the slopes from each side being the same. If they were different, once you got to that point in the middle, at x equals 0, you might have like a cusp or a corner or infinite discontinuity. So, yeah, I'm just taking the limits, not the limits, the derivative from both sides, which means I'm just taking the limits of each of my functions from this, because that's from the left side, and this, that's from the right side. So the derivative on the left side would be cosine, or cosine, so it's chain rule, cosine 2x times the derivative of the inside, so that would be the 2 there. And if I plug in a 0, that means, what would this be? Cosine of 0 is 1, so that would be 2. So evaluated at x equals 0, that would give me 2. So the derivative on this side, well, that would just be m. And if I want it to equal the derivative on that side, to avoid a corner or a cusp or whatever I just said, then you would have to, m would have to be 2, right? So m equals 2, so that the left and the right derivative agree. And that's it. There you go. That's the explanation. I'm not writing that down. Adios.